Regression analysis, we understood when two variables are related, you will have correlation. Okay, and that correlation should be in a particular way. So that is correlation. Now coming to regression, we'll understand what is regression here. It's a statistical tool which will help us to understand the position of the variable, and it will also help us to estimate the unknown value of the variable. Now this is the main concept which we used in time series chapter. Okay, the equations which we found and the simultaneous equations which we tried to solve. Okay, all that equations which we try to solve, everything is part of regression analysis. Fine, so let us see the definition. So Richmond has defined regression as the technique for derivation of an equation by which one of the variables, that is the dependent variable, may be estimated from the other variable, that is independent variable. Now in correlation we understood that x would be usually the independent variable and y will be the dependent variable. So y will be dependent on x. So by knowing one of the value, by knowing either the value of x, if we know the value of x, we'll find y. If we know the value of y, we will be finding x. So by finding this, we can estimate the future required value. So that technique of deriving the values for these variables is known as regression. That is the definition given by Richmond. Now one more definition which is given by Blair, which says regression analysis is a mathematical measure of an average relationship between two or more variables in terms of original units of data. He simply says it is the average relationship. Okay, and the basis is the original units of data. So if you remember in correlation, we took the original data and found out x, y, and x square, y square and all that, right? So that is original unit of data. So that data, if you consider and find the values of the variables, that is x and y, then also it is regression analysis. Then one more definition by Yo-Lun Cho. Regression analysis attempts to establish the nature of relationship between the variables. That is to study the functional relationship between the variables x and y, and thereby provides a mechanism for prediction of future, for predicting or forecasting. So if you want to get the sales of, let's say, 2022, even considering the present scenario, you want to estimate the sales of 2022. You can do that by using regression analysis. So here you will be finding the relationship between the two variables, that is x and y, and that relationship will be functional in nature. One is a dependent data, the other one is an independent data. So we are trying to understand the nature of both the data to find the original values, so that we can use them to predict the future values. It is a prediction, it is not the actual data. Prediction means what we think it will be, but in 2022 it may be same, it may be different. Okay, so that is regression analysis. Did you all understand what is regression analysis? Type in the chat box. Everybody is clear? Next, dependent variable and independent variable. So one of the variable will be dependent on the other. So that variable which is not dependent, no, that is called as independent variable. So there are two types of variables in regression analysis. One will be dependent. It depends on the other variable to get the value. The other type is independent variable, where it won't depend on anybody and it can derive its own value. So let us see. Dependent variable is one which value is influenced by other value variable. If there is a slight change in x, the y will change. That is known as influence. If your friends can easily influence an individual, right? So there are dependent and independent values. In other words, the variable which is to be estimated or predicted is called as dependent variable. Okay, if I want to predict the sales, that is a dependent variable. Okay, this dependent variable is also known in few other names, that is regressed, explained, predicted variable. They are called as regressed variable, explained variable, predicted variable. So what's a dependent variable? It is one which get influenced by the other variable. Now coming to an independent variable. Independent variable is one which influences the other variables. So here dependent is getting influenced, right? So independent is going to influence the other related variable. Independent variable will try to control the other variable, so it can be used for predictions. A variable which is used for predictions are independent variable. And this are the other names for independent variable are regressor. Here if you see regressed variable, ed is there. Here it is or, regressor variable. Predictor, it is predicted. For dependent, it is predicted. Here, who is predicting that? Independent variable. So it is called as predictor variable. And here for dependent, it is explained. How it is explained? Who is explaining it? Independent variable. That is why it is explainer. Okay, regressor, predictor, or explainer variable. Fine, let us see an example. By example, we will be able to understand. For instance, if we know the interrelationship between selling price and demand for a product. Let's take for example the masks that we are using today. There is a huge demand for the product. So you'll be able to get a mask at 20 rupees, 30 rupees, 40 rupees also, right? So the relationship between the selling price and the demand. So we can find out the quantity demanded at a given price of product and also predict the probable price of the product to achieve the given quantity of sales. So we by knowing the relationship between selling price and demand, we can find out what is the demand for the product. How many units of product are demanded? Let's say at 20 rupees. 20 rupees mask, how many are demanded? 30 rupees mask, how much is the demand? 60 rupees mask, what is the demand? 150 rupees mask, what is the demand? 200 rupees mask, what is the demand? Like this, we will be able to understand at different levels. So that is possible by regression analysis. So thus, here if we are estimating demand at a given price of product, demand is the dependent variable and the price will become the independent variable. Okay, the demand of the mask is dependent on the selling price. Okay, maybe the 20 rupees mask is being sold out more. Okay, let's say per day 1000 masks are being sold of 20 rupees. So here price is the independent variable. It is only influencing the demand. Because of price, more people are coming and buying that variety of the product. So by analyzing the situation, we will be able to understand which is the dependent variable and the independent variable. Okay, so both the variables will be closely related, but there will be a difference. So that is dependent and independent. Then there is one more type you will come across in the problems, that is interdependent variable. Okay, now in this interdependent variable, that means when first variable is taken as dependent, the second acts as independent. Now if both selling price and demand are depending on each other, then it is called as interdependent. Now in such case, if you take selling price as dependent, the other one will become independent, that is demand. But if you take demand as dependent, selling price will become independent. Just for the sake of problems, we'll have to differentiate these interdependent variables. If not, they are very, very closely related and they are very similar also. Okay, so by comparing two variables, by finding to understand the relationship between two variables, we will be able to come to a conclusion of two regression lines. Okay, now what are these regression lines, we will understand. And regression lines will be two lines. It is not one, it is two lines. One line for dependent variable, one line for independent variable. Okay, now if you understand, one line for x, one line for y. Okay, did you all understand dependent and independent? Did you understand this slide? Any doubts here? Okay, now let us understand what are regression lines or estimating lines. Now a line of regression is a straight line which gives the best estimate of one variable for any given value of the other variable. So it's in a simple, very, very simple words. They will give you the value of x. By substituting the value of x, you will find the value of y. That's all is regression line. If at all they have given you the value of y, you'll substitute that in the equation and find the value of x. So here you know one of the value, either x or y, one value you will know. So using that one value, you will be finding the other value. Okay, now let us see the definition given. The device used for estimating the value of one variable from the value of other. They are repeating the same thing. If you know the value of x, from that you can find the value of y. If you know the value of y, from that you can find the value of x. Okay, consists of a line drawn through the points in such a manner as to represent the average relationship between two variables. Now what they will do, they will know all the values of x. How we did it in the time series? We came up with an equation. We substituted the value of x where we found the value of y. Correct? Now we went on to a graph sheet. In that graph sheet, we first marked all the values of x and we also marked all the values of y. Correct? Now those lines, when you join all the dots, you'll get a line. That is called as regression line or line of regression. This regression is very, very much combined with the time series. Okay, that's why the continuation of this will be the time series, which is second chapter. I did the chapter first because that was much easier to understand than correlation in the first place. Okay, so we can do a revision after this. That's not a problem. So that's why we are going to use the same method here to solve the problems of regression. Okay, so that is regression lines. Now in regression lines, there are two variables which we will be using, that is x and y, and so we will have two lines. What are those two lines? The regression line of y on x. Okay, first scenario where it is line of y on x values. The second scenario where the line of x on y values. Okay, so be very careful while solving these problems because you can get confused with y on x and x on y. Okay, this is the only place where students go wrong. So when we go to problems, you will understand it better. Okay, now what does this say about? The regression line of y on x gives the most probable value of y when the values of x are given. See, same thing again. What does this mean is, when the values of x are given, they will give you x is equal to 5, 6, 7, 8, 9, 10. Okay, you have a regression equation. Now you will substitute all the values of x separately there. X is equal to, substituting x is equal to 5 in equation 1. You will solve. You will get y is equal to 3. So when the values of x are given, okay, when the values of x are given, you find the values of y. That is regression line. See, understand the sentence. Regression line of y. Regression line of who? Y. On x, on the basis of x values. Similarly, regression line of x. Here, which values will be given? Values of y will be given. So we will substitute the values here and we'll find the values of x. Clear? Understood? Did you all understand this two types, two major regression lines? Yes or no? Okay. Now, in first regression line, okay, in first regression line, that is y on x, whatever comes first, that will be the dependent data. So in this first type, y is the dependent data and x is the independent data. In the second one, first what is there? X. So x is the dependent data and y is the independent data. I'll repeat it again. Listen carefully. Whatever comes first is the dependent data. This will depend on the other value. So y will depend on x values. Here x will depend on y values. So first one is the dependent value variable. The second one is the independent variable. Okay, so those are regression lines. And there's a definition for regression line given. A few times they have asked this for 2 marks question. Okay, a definition of regression, then types of regression, 2 marks question they can ask, and what is, explain what line of regression can be asked. Okay, line of regression of y on x is the line which gives the best estimate for the value of y. See, the best way to remember all this is by understanding. Only if you understand, you will not get confused with x and y and you will be able to write. Okay, let's read that together. Line of regression of y on x. When it is y on x, it means x values are given and you have to find the y value. Is the line which gives the best estimate for the value of y. We have to find the values of y for any specified values of x. So x value will be given. And then line of regression of x on y. Here you will have to find the best estimate for x when the y values are given. Same thing, they are repeating it over and again. One value will be given, find the other one. Okay, next, the term best estimate or best fit. See, this we will be using in the problems. Best estimate or best fit is interpreted in relation to principles of least square. I am sure you remember this method which we solved in moving averages, right? Principles of least squares, which consists in minimizing the sum of squares of the deviations between the given observed values of the variable and the corresponding estimated values. So this value of sigma y minus y bar whole square should be minimum. So we will understand this by going to the problem. Okay. So before getting into the problem, you should understand the equation. So firstly, the equation of y on x. So here you will have to find the values of y when x values are given. Now what is the equation? Yc is equal to a plus bx. Do you recall something by seeing the equations? Do you recall by seeing the equations here? We have solved all these problems in number series. Graph problems. Yes or no? So here YC stands for value of Y computed from the relation given below for the given value of X. They are repeating the same thing. Let's just see what is important. Here A is the intercept. YC is the value of Y which we will find, and A is called as the intercept, which determines the level of distance with the line above and below the origin. And B is the slope of the line. Okay, B will say me at what angle which where the line regression line has been there on the graph. So A is the intercept, B is the slope of the line. That you should remember. Okay, now how do we solve this equation? Now to get the value here of A and B, we have to solve these two equations. Sigma y is equal to Na plus B sigma x. Sigma xy is equal to A sigma x plus B sigma x square. Okay, so let us see what all it means. Sigma y is nothing but total of variables of y. Sigma x is total of values of x variable. N is number of observations. Xy is when you multiply them and add them. X square is sum of squares. We have done so many problems using all of this in the correlation. So let us get into the problem. See, this is the other way around. This is x on y and this is the x equation, and these are the equations that you'll be using to solve the values and put it here. Okay, so let us go to the problem directly. I think this will make more sense in understanding. Okay, before I get into the problem, any doubts until here? The theory of regression, theory of correlation is important because they can ask you 2 marks question, 6 marks question can be asked. What is dependent variable? What is independent variable? What is best fit? What is probable error? These are most repeated questions which you can see on the question paper. Okay, so okay, let's start with the problem. Now, from the following data, obtain two regression equations. Both the equations we have to get from this data. So we have the value of x given and value of y are given. Then hence predict y if x is equal to 5. Read the question. Predict y. You have to be careful in your English here. You have to predict the y value. If the x value is 5, okay, so this is y on x. X value is given and you have to predict the y value. And predict x if y is 10. So this is x on y. First one is y on x, where x value is given. Second one is x on y, where y value is given. Let us start the calculation. First, formulation of regression equations. Heading is very, very important in any part of statistics and mathematics tables. Without heading, if you write, the answer does not make any sense because nobody will understand what you are calculating. So give the heading formulation of regression equations. Then copy down the values of x, copy down the values of y. Okay. Now, according to the formulas, according to the equations, we require x square, y square, and x into y. These are the values we require. So we will square all these values, x square. So 3 square is 9, 6 6 are 36, 9 9s are 81, 10 10s are 100, 7 7s are 49. And again we will square the y values. 11 square is 121, 8 square is 64, 7 square is 49, 6 square is 36, 8 square is 64. So we got all the squared values. Then after that, multiply x into y. When you multiply x into y, you get the values of x, y. Now total all the columns. Sigma x, when you add all of them, you get sigma x, was first important number. Sigma y, when you add all the values of y, you get sigma y, second important number. Then thirdly, sigma x square. Fourthly, sigma y square. Then finally, sigma xy. These are the 5 important numbers that we require to solve the equations or form the equations. Okay, so this is your table calculations. So any doubts in the table calculation? Any part you want me to explain it again? Understood? Yes or no? Understood? Okay. Now let us go to the equation. Now we'll go to the equation and we will start solving. Now they have asked us to fit 2 regression equations. Now what are the 2 regression equations? First is y on x. Regression equation of y on x. Now for y on x, the regression equation is yc is equal to a plus bx. Now to get the values of a and b, we have to solve these 2 equations. So to find a and b, solve the following simultaneous equations. That is sigma y is equal to na plus b sigma x. Sigma xy is equal to a sigma x plus b sigma x square. Okay. Now let us check what are the values. Sigma x is 35. Sigma y is 40. X square is 275. Y square is 334. Xy is 260. Now we are going to substitute all these values here. So sigma y is 40. N into a. What is n? What is the number of data? 1, 2, 3, 4, 5. So n is equal to 5. So n is 5. 5 into a. We don't know a. We will write it as it is. Sigma x is 35. So 35b. Then sigma xy is 260 is equal to sigma x is again 35. So a will remain as it is, 35a. Sigma x square is 275. So 275b. So 40 is equal to 5a plus 35b. 260 is equal to 35a plus 275b. These are the 2 of the equations that we will be getting. Now, these 2 equations are to be solved simultaneously. Solved simultaneously. So when you're solving it simultaneously, it means that you are supposed to equate one of the values. Now, when you see here, you have, okay, let me erase this value here. Okay. So when you see here, you have 5a and there is 35a. Right? This only, I'm only taking this part, 5a and 35a. I want to equate this. I want to make this 5a also as 35a. How do I do it? I can do some multiplication. So 5 into 7. 5 into 7. 7 5s are 35. Right? So I cannot multiply only 5 with 7. I cannot multiply only 5 with 7. So what I will do, I will multiply the whole equation with 7. I'll multiply the whole equation with 7. So what do I get? When I multiply the whole equation, I will have what? 40. See, 40 into 7 will give me 280. Take a calculator and check. 40 into 7 is 280. 5 sevens are 35. So 35a. 35 into 7 will give me 245b. Okay. So this is my first equation. I hope you all remember how to solve a simultaneous equation. I'm just explaining it over and again so that anybody who doesn't know, they'll be able to solve it now. So the first equation, the whole of first equation is being multiplied with 7 because I wanted this 5 to be converted to 35. Now, when you see the second equation, now before going to second equation, did you understand the first equation? Did you all understand how to solve it? You guys have to reply quickly so that I can finish up this question. Did you all understand? Yes, no? Yes, everybody understood? Good. Now going to the second equation. Now see the second equation. Now the second equation is 260 is equal to 35a plus 275b. Now here for a, there is already a 35a here. Correct? For first equation, I multiplied and I made it 35. But second equation is already a 35. So what I will do, I will not change anything. So I will just multiply this whole equation with 1. So if I multiply it with 1, it will remain same. The values will not change. So 260 is equal to 35a plus 275b. Okay. So I will have the same equation. Now let us subtract the equations. When you are subtracting the equations, you are supposed to change the signs of the equation. Okay. When you add the equation, you need not do anything. When you subtract the equation, the rule is you have to change the signs of the second equation here. So when you change the sign of the second equation, what will happen is, if it is plus here, if it is plus 260 here, it will become minus 260. If it is plus 35a, it will become minus 35a. If it is plus 275, it will become minus 275. Okay. So that is the values that you will be doing. You will change the sign, and then once you change the sign, if you see here, plus 35a and minus 35a will get cancelled. So I am eliminating one of the variable so I can find the value of b. So I will take out a. Now do the other part. 280 minus 260 will give me 20. 245 minus 275 will give me minus 30b. Okay. Now next step, 20 divided by minus 30 is equal to b. And then you will get the answer in minus. 20 divided by minus 30 will give you minus 0.06667. Take 4 decimals. Because here most of the part it is decimals only. So that is why take 4 decimals. So we know the value of B now. Okay. Now substitute this value of B. Substitute this value of B in one of the equation. We have taken the first equation. If you see here, this is the first equation. We have taken that equation here. And in this equation, we are substituting the value of B, that is minus 0.6667. Fine. When you substitute it and when you do the simplification, 40 is equal to 5a plus 35 into minus 0.6667. 35 into minus 0.6667 will give you minus 23.3333. Okay. And then 5a, take 5a to the other side, take 40 to the other side, interchange the sides. Now you will get 40 plus 23.3333 and a is equal to, if you add both of them, you get 63.3333 divided by 5, and the value of a is 12.6667. Okay, so we found the value of a and we found the value of b. So by using these two equations here and solving them simultaneously, we got the value of a and we got the value of b. Now this value of a and b is supposed to be substituted in this regression equation, and that will be the first regression equation. Okay. So if you see here, now put the values of a and b in this regression equation, and that is what you have here. Y is equal to 12.6667. This is the value of a minus 0. Y minus, because the value of b is minus 0.6667. This was the value of y, sorry, b. And that is why that minus is also carried forward, minus 0.6667x. So this is how you fit a regression equation for the y on x. Did you all understand this part? Any doubts until here? It's a compulsory question which you will get for 14 marks. It's very easy to solve. If you solve 2-3 problems, you'll be able to catch it up. Everybody understood? Okay, great. Now, let us just finish this part quickly. Now, going back to the question, they have asked, predict y if x is equal to 5. Okay, so here x value is given to us. So we already know what is the value that we have to put here for x, and we can find the value of y. So write down that equation again, and then in the place of x is equal to 5. So x is equal to 5, if you put, the value of y is going to be 9.